Good afternoon, everybody. Move on up. We have all these nice tables with the QR codes so you can submit questions. Excellent. My name is Jan Regt from Flight Safety Foundation. I'm here with my panelist of experts to discuss air traffic management systems of the future. First, we have Michelle Bishop, who is a director of programs at the Civil Air Navigation Services Organization, manages CANSO's global safety operations and strategy programs. She leads the development of policy on key issues affecting global ATM industry, and she currently leads CANSO's involvement in the Complete Air Traffic System, CATS, future vision, which has been developed in collaboration with over 80 aviation stakeholders from around the world. Our next panelist is Alain Sibert, who is a senior European official responsible for setting the strategic direction for the Single European Sky ATM Research, CESAR, and its implementation in CESAR 3 joint undertaking. In this position, Alain organizes and manages collaboration with a broader stakeholder community with regard to the future of air traffic management and EU policy. And our third panelist is Parimal Kopdekar, who serves as director of NASA Aeronautics Research Institute, NARI. Previously, PK has served as NASA's senior technologist for air transportation systems, and he invented the Unmanned Aircraft Systems Traffic Management System for managing drones operating under 400 feet. His pioneering work in autonomy, advanced air mobility, and drone airspace integration is shaping the future of aviation, balancing safety with innovation. Please welcome my panelists. So Michelle, would you like to go? Loud. Would you like to tell us about CATS?
I will. Thank you, Jan. As Jan indicated, I'm with the Civil Air Navigation Services Organization. We are the industry association for ANSPs around the world and ATM supplier base. So we are the IATA of ANSPs. And this is an initiative that we launched, the Complete Air Traffic System, or CATS, Roadmap for Future Skies. This is an initiative we launched back in 2001 in an effort to build a coalition of, a broad coalition of industry looking at future ATM systems and what the needs of our future skies were going to be. We have ANSPs, airlines, airports, the professional labor associations are involved, the new entrants and advanced air mobility and commercial space operators are involved, and a lot of the tech disruptors in the space as well. The supplier base as well as the MROs have been actively involved. And we initiated this process because there were concepts of operations that were emerging in different silos. There were different ideas of what the future might look like, and we really wanted to bring everyone together in the big tent approach and wrestle through all those ideas and get an aligned vision of what that future was going to look like, and then start working towards it. So
that is not the slide that's showing. If you wanted that slide to be showing.
Then what I'm seeing on the screen is not what's up there?
No. So click it again and see what happens.
What's she saying?
I don't know.
Oh, it's showing on the outside.
Oh, okay. Sorry.
Good then.
Sorry.
We're good then. So it really is about bringing together that diverse group to wrestle through the visions and shape the skies together. There is broad consensus that this is a moment in time at which aviation needs to do this. When we put out the call for action to bring everybody together, there was broad consensus that this is the time, that the growth in traffic, the immediate, onset of new entrants and drone activity and urban air mobility, the growth in commercial space operations, we need to be wrestling with this issue now. We also believe strongly that incremental change was not going to be the solution, that we needed to think outside the box as a community and rethink the transformations that we need to go through as a broader community and enunciate those and start developing a path forward on them. So what we've been working on for the past 4 years is we've put out a vision for the future, we've put out a roadmap to that future, and in April, just a few months ago, we released a concept of operations, and it's primarily the concept of operations that I want to talk to you about. It is a vision, we call it Vision 2045. I won't be hard on that date. I don't think anybody's going to be upset if we achieve it in 2048, but we wanted very much to lay out a message of ambition and urgency, and that's part of the reason we landed on 2045. So the concept of operations goes through how we are going to get to an era of data-driven decision-making, an era of a new role for humans in the system, and some of that has been talked about this morning in some of the other panels, and we very much deal with that, and how we will leverage automation to optimize the system on an ongoing basis. We did sit down, like all good concepts of operations, and curve out what our sort of North Stars were. What were the principles that would power the vision? Safety is obviously the foundation. You will hear that throughout the week this week. Everything that we build will start there, but we have other priorities as well that the system needs to meet. Sustainability needs to be embedded at its very start. We need to take a different approach to performance management, and that's something that I think we'll talk about later. Equity of access for all airspace users is a principle that we will design the system based on. Cybersecurity, cost-effective and scalability, and that global collaboration and that interoperability is something that, as a global organization, we're very focused on. The concept of operations identifies a few big leaps. It curves out what it sees as foundational transformations that will be the enablers, the building blocks we need to be taking action on now, and then those bigger leaps that will deliver performance breakthroughs. There's some of the boring stuff we need to get done first, but some of the real performance breakthroughs are coming. And this is a very busy slide, and you can go to the concept of operations and take a look at it in more detail, and each one of those transformations is described at length. But we've identified 16 transformations, 8 being foundational and 8 being more transformative, that we believe that the industry needs to be focused on now. You will see along the bottom there, the regulatory framework is a sort of overall underpinning, and we're having lots of conversations about the changes that need to be made to our regulatory framework to enable new approaches to how we certify our systems and allow us to progress with innovation at a higher pace than we've been able to in the past. So there's lots of those conversations, but you'll see there the sort of the digitization. You'll see a few transformations that might surprise you a little bit, but we had a really robust process to sort of end up with these 16. I think we had a longer list at one point in time, but these really are the core transformations that need to occur on a global basis to deliver the future end state that we envisage. The concepts of operations then describes the phases of how we get to 2045. It's great to talk about that vision of what we think those future skies are going to look like, but the how we get there is critically important. And phase 1 is all about advanced digital information sharing, how we get to broad-based SWAM, how we digitize the essential information that is in our system and make it more broadly available. Phase 2 is all about how we advance smart automation, how we free up resources from the tactical tasks that they are doing right now and achieve, trajectory-based operation on a different scale. And phase 3 is really where we achieve seamless skies. We are adamant throughout the concept of operations that airspace integration, not segregation, is the only viable solution for the future. And getting to seamless skies through these steps was really important to how we framed it. There are lots of things in the concept of operations that are future, but I would say that future is already emerging. There are key essential parts of this that are starting to happen now that we're seeing. Digitization is the focus of all ANSPs that I talk to globally on how we achieve that really important critical foundational step. Virtual centers, Europe has virtual centers now and has made that a priority. Trajectory-based operation trials we're seeing happen across regions, not just within ANSPs, but on a regional basis in places like Asia. Cloud-based ATM, that is absolutely core to everyone's strategy right now. Artificial intelligence, we're seeing being brought into operations in really interesting ways, and many of the leading ANSPs are using AI digital twins right now, not just for research purposes, but to optimize airspace performance on a daily basis and to help inform some of the strategic decisions that they make. We are clear, unlike some other processes, that we went through this process not just to develop a vision for the future, but to turn that vision into action. So as the CATS Global Council, as a body of organizations, we have elected to stay together and to keep working this over the next decades. We have a rotating 3-year work plan where we're advancing some of the near-term items and doing some of the road mapping now. But it's interesting to see how the consensus has shifted and how that prioritization and the nature of the conversation amongst the different parties has certainly shifted over the last little bit. So it's been an interesting process. If you're interested to read more, there's a link there where you can download our full concept of operations on our website, futureskyvision.com.
Thank you.
Thank you.
All right. Alain.
Thank you. Good afternoon, everyone. I will do my best to present you the European vision at 1 o'clock in the morning for me because I just arrived yesterday. A few words about the organization I work for. We are a body of the European Union. We have 3 missions. One is to define the EU ATM modernization priorities and roadmap. And that is essentially what I will present you. We have a second mission, which is to concentrate and coordinate all the R&D efforts in Europe. So that's from TRL 0 to 6. And a third mission, which is rather new, which is to actually help the deployment into operations of those technologies. And this is where we engage very much with EASA in Europe, but also our colleagues across the globe to make sure that the regulatory framework is supportive of those new technologies. We also sponsor some implementation projects for pilot implementations. And we work with standardization organizations to make sure that the standards are there. So we are a very cool organization because we can just focus on technology, and I can be the kind of techno-optimist in the EU administrative institutional framework. And then I need to wrestle with my colleagues, the regulators, to make sure that we see the world in a similar way, a bit like my colleague PK does it with the FAA, I presume. It's also in this context that we collaborate internationally because we don't think that a European-only approach, at least for some of the problems we are trying to solve, is going to be the answer. We just updated our vision for Europe. It's a vision that really takes into account, on one side in Europe, still a very strong climate imperative. We have a political push that by 2050 our sector should be carbon neutral. Politicians see ATM as the easy equation to solve and the cheap one compared to the huge investments that need to go into developing the next generation aircraft, into developing the next generation fuels. We also have a completely different security context in Europe that has shaped this vision. Here I'm just showing to you the impact of the war in Ukraine with 20% less airspace available for traditional commercial usage of airspace, significant increase in cyber attacks. I'm sure many of you are also aware of the significant spoofing and jamming challenges that we are facing. So the security dimension of ATM and the security posture is really taking also center stage in this debate. Last, and in no particular order, there is a return of capacity and scalability challenges. Just when COVID hit, Europe had reached its capacity limit in terms of airspace usage. Now, for the If everything goes well this year, we will be at the same traffic level as in 2019, but we already have higher delays and congestions than we had in 2019. So this is just the challenges. If I mention, I would say the top one, there are many more. So we came up with a unified European vision, which calls for a very bold establishment of Europe as the most efficient and environmentally friendly sky to fly in the world. It's not meant as a competition statement, but more as an let's try to solve a big problem together type statement. And our vision is that the ATM system needs to be fundamentally redesigned to bring trajectory optimization at the center of ATM at a level where by design, not by exception, every flight is optimized at very precise, in very systematic ways, down to the tail specification of the energy performance of each aircraft. Today, we try to do that when there is spare capacity, when you are the only one in the airspace. Tomorrow, we want to do that by default for every flight. We also want to be sure that we are changing the way we are seeing the design of our core systems by adapting more of the capabilities that have been adapted in other safety and security critical sectors. So we are talking about the implementation of a new service delivery model, which means nothing more than actually to have systems that are more open, that leverage infrastructure that is not just cloud specific, that relies on modern system architecture design, and that enables for a world that looks like the future and not like the past. We also see that we are not going to be able to have a system that delivers the performance that is needed without embracing higher levels of automation for ATC. So we actually see in our vision that at a 2045 horizon, or 2050, as this is a theme of the panel, for certain phases of flight, under certain conditions, the system will be fully managing the flight. There will not be any need for an air traffic controller intervention. And here I'm not talking about UTM-type operations or smaller drones, but we are talking about commercial flight. So we also recognize then that in this we will have a significant evolution of the role of the human going towards a notion of human-machine teaming. So to get there, we think that we need to place much more focus than we did in the past on 5 key transformation levers. We need to get really serious about trajectory optimization and not, oh, I'm going to give better information here, this will help me improve a little bit there under these conditions. No, if we would like to have a system and a service of ATM that by design optimizes every flight systematically, not just in the pre-flight phase, but also in the execution phase, how do we need to think of it? And we came to the conclusion that we need a system that is much more capacitative than it is today by design, that embraces much higher data volume users than it does today. I'm sure we'll come to it. We often say in our sector that we should be better at using data and so on and so forth and trust each other to share data. Yes, but today we are already in a situation we are not leveraging data that exists just because of the way our systems are designed. Weather is one example of this. If we leverage more data, which means we want to be more precise, we want to be more systematic, we want to do global and local optimization, a human brain cannot do that and process all of that information. We need to embrace more automation. And if we do embrace more automation, we need to rethink how we allocate airspace to traffic, to digital assets, to human operators, and move towards, how would an airspace be constructed and managed if we have digital assets to manage them? And it's a very different allocation of resources and the role of the human. Enabling all of this, we emphasize often we need a new way of delivering services in ATM, that's the core system design, and we need a new way to regulate systems and services in ATM. So we put that in a roadmap that is here at a very aggregated and simplified version. There is much more information available. where in terms of bringing things into operation within the next 10 years, we think that we can bring better implementation of trajectory-based operation into operation, but here we are still talking about not revolution, better information of flight plan information, better global harmonization of these exchange and collaboration, primarily in the planning phases, leveraging as much as possible current air-ground connectivity standards. We are thinking about relatively simple clearances, but let's do it systematically. In terms of automation, it's about introducing more automation support. It's about utilizing virtualization techniques to enable a more dynamic utilization of airspace, but it will remain a human-centric system. At 2045, this is where we would be in a system where, for certain phases of flight, the flight would be handled by automation, where we have this human-machine teaming that is implemented under certain conditions. Maybe not often, maybe not everywhere, but at certain times of the day, under certain conditions. And these dates that you see here are not research and development dates, but they are dates at which we would operate in this model. So our roadmap, for instance, gives challenges that are pure implementation challenges. We are giving ourselves 10 years to fundamentally rebuild and redesign the way the core ATM systems are built, operated, and certified in Europe. And here I'm not talking peripheral systems. I'm talking flight data processing systems. I'm talking tower systems. I'm talking ACC core systems, where we will have a system where you have a decoupling of the controller working position, the core ATM system itself, and the infrastructure, CNS, etc., so the on-site specific, to move towards one that is purely data-driven, service-oriented, where you can actually think of upgrading an ATM system not every 15 years and recertify like we do today, but maybe start having it on a yearly basis, if not earlier. One of the reasons for that is also to unlock a lot of hidden talents and resources in our sector that today are locked into maintaining old legacy systems. It's also about being able to improve the security of our systems, because today, if you want to have a security patch on any of our systems, you probably can't. Whilst it is best practice to do that much more often. This is a radical change in the way systems are also certified, the way we provide software assurance, et cetera, et cetera. So it's a huge domain. Happy to answer any questions later. I know that many of the ideas that we have would not be a part of the formal EU vision, and this means blessed by all EU member states, et cetera. I pass you all the processes we have to go through without the innovative ideas that came out of the drone UTM space. So this roadmap is somehow making sure that we are creating the space for advanced and innovative air mobility solutions and services to take place, whilst we adapt ATM, but it also shows a convergence as we move forward between those two words. In terms of pure research and development, for the next 5 years, we set ourselves only 12 priorities. We said we need to be more focused. And here they are listed. They are from science to actual prototype development. And this information you can see in our master plan. Just 2 examples to show you how far we go. On the science side, we are very much putting effort now also on the climate, the contrails, etc., and reducing the uncertainty also from a scientific perspective there, so we can start implementing solutions in our systems. From an industrial development perspective or industrial prototypes, it's really about developing the next generation core ATC systems for high levels of automation. And on this, we have an automation roadmap where up to now we have focused mainly on what we call automation level 0 to 2. And we are now stopping our investment in this area, because being focused also means stopping certain things. And we are putting all of our investments on capabilities that will bring us to level 3 and 4. This is because we think that the level 1 to 2 challenges can be solved by a company, by a stakeholder, but the level 3 and 4 challenges can only be solved by tackling them together. This is my last slide. I haven't heard so much about, like, say, benefits and so on so far in the conference. We also put that together in terms of what does it mean in terms of value at stake. There is no one, no politician, no company, no stakeholders that can say that this is expensive, this is hard, this is impossible. If you put this in comparison, implementing a completely new air traffic management system while still running the old legacy systems for 15 years, doing the transition, costs less than 40 billion euros for Europe. It's so much less than what it costs in investment to develop the next generation aircraft, the next generation fuels, and it brings so many benefits that outweigh by far the investment costs. We talk about less than €1 per flight. I mean, it all depends on us to make it happen. And here is my last slide if you want to know more about CESAR.
Thank you.
Okay. Thanks for the opportunity to share our views from NASA perspective. It's always great to see 50 people here. Anytime there are more people in the audience than podium, I call it success. So this is a good step. I'm here to talk about future aerospace operations. Much of the discussion actually has already started. Many points are already covered, but I'll share some new ideas that we are chasing. So ideally, we want to say that the current situation is not sustainable. If you look 50 years from now, and the types of density and the complexity and the types of vehicles that we are going to have, can we accommodate all of them with very high efficiency, productivity, and safety? That's sort of our challenge. How do we do that? So I'll talk about that situation. I'll talk about the evolution that has been happening in airspace and safety, and then look at the future. So why do we need to change? That is a fundamental question. Anytime government is asked that question, because there is a lot of money involved, capital investment, so why do we need to change? So obviously societal expectations from space operation, anything with air transportation are evolving. They want to be low noise, they want to be very efficient, they want to be basically friendly towards what's happening in society and their expectations in terms of health and safety. So technology around us is evolving, changing rapidly. There's better networking options, better Internet of Things options, better electrification, better autonomous systems, better algorithms, cloud systems, all kinds of new things are happening that we need to figure out how to take advantage of. And large-scale system upgrades in today's world take too much time and cost. Everything is sort of a solution that's integrated with hardware and software. So if you need to upgrade, takes a long time and a lot of money. So can we do that in a different way in terms of architecture? And then the new entrants need quicker access and sustained airspace access. They really want to be ready, whenever the certification is ready, they want to be able to fly very quickly. And then as the last point is density, diversity, and complexity will continue to push boundaries. And current system and architecture is just not going to keep up with that, as we know. So that's the reason why we want to change. Now, if you look at the history as to how we got here where we are, first epoch was basically procedural separation, flight strips, and even before that was basically trim boards. But let's start with that. And safety, of course, was the focus. The next came radar, where we can know the position and we try to estimate the position in the forward. That allowed us to get more confidence and get more density. Then came trajectory-based operations, and we are still in that area. We are kind of straddling between 3 and 4 epochs. Now, the efficiency and proactive planning, so that we know that position, and then we can figure out what the planned aircraft position is. 4-dimensional trajectory management. And then came digital transformation started about that time, and then came the collaborative, cooperative kind of operations where we can start to inject some service-oriented architecture. and some tailored missions and then try to exploit third-party services, which is what we're doing in unmanned aircraft system traffic management. We're exploring that in ETM, which is upper E traffic management, and so forth. So there is, along the way, there is a safety continuum at the bottom in the orange color that you see, predictive risk assessment and management of that. And then where we are headed is basically highly automated AI/ML-based system, which is very dynamic, maybe robust in performance and safety and risk management in a dynamic manner, rather than very static. So machine-to-machine interactions, and then humans will be collaborating with that. But fundamentally, we want to move towards a machine-based system that is going to make very rapid decisions based on available information, and humans will be in charge of basically overseeing that kind of setup. So the complexity, scalability, and dynamic adaptation is really critical as we move towards future. If you just take example of commercial space launches, almost every year they are doubling. And if you continue on that path, it's going to be very interesting, what kind of future we see. And then there is information that needs to be exchanged with the operators that are doing commercial space launches, all the way to the drone operators, and the system has to keep up with everything. So what does future system look like? So I'll talk about some example opportunities. So we have an initiative called Sky for All, and we'll be coming out with a lot more details. There is already a website. If you check NASA Sky for All, you will see some information there. The more details are coming soon. But idea is basically how do we prepare ourselves for future? And one of the fundamental things shift is the total system performance, and that's simultaneous. So if you look at the current system, safety, safe, expeditious, orderly flow. That's sort of the sequential order in which the ATC system works today. And obviously, because of the human-centric nature, you have to prioritize safety first. Then, if you have time, you do efficiency, and then you have time, then order. But in the future, if you have the kind of density, diversity, and scalability that we are expecting, you need to be able to do all of that simultaneously, and that can only happen through algorithms. So we need algorithms that can optimize around all these multiple objective criteria rather than just one singular criteria. That requires a different trajectory prediction. So current trajectory prediction is only 4-dimension. We want to be able to predict safety. We want to be able to predict basically what the emissions would be. We want to be able to predict what the noise will be, and then basically exact location. So all of that need to be part of this total system performance assessment. Then aerospace simplification and dynamic changes. Again, we have aerospace classification. That classification exists so that humans can cope up with the complexity that's currently expected because we didn't have good tools and algorithms in the past. So we had humans doing all of that work. So the airspace structures exist to be able to simplify that kind of structure so that there is a basically predictability where the conflicts will be, where everybody is going to arrive, where everybody is going to depart, and so on and so forth. So cognitively, it's possible to track everything. However, if we are moving towards future with that kind of density and scalability and safety expectation, it may not be possible to do that through human cognitive limitations. So we need automation again to be able to do that. The question is, do we really need the same type of airspace classification? Can we simplify airspace? Can we generalize airspace and make dynamic changes to the airspace? Third is cooperative operations. So think about future. If everybody had on a network and everybody sharing the information through network, which is basically your current position as well as predicted position, then things change completely. You become almost a cooperative, basically share and care type of environment, rather than having to depend on a central entity to make all the decisions, because the central entity is the only one that has all that information. Now, if you share and care all the information with all the operators, then the things change. This class of algorithms called Hamilton-Jacobi partial differential equations, and you can start to look at basically what flexibility boundaries you have around your trajectory and say, well, can I move without having to actually ask or get the clearances? So even if you say that I will still need some kind of clearances through machine language or machine-to-machine interactions, you at least have an idea as to how much flexibility I have around my trajectory, because you have the information about not only yourself, what objective criteria you're trying to meet based on your business trajectories, business goals, but you also know what is around you, what constraints exist, what other operators exist. So it's a very interesting, fascinating topic for those who are students or in academics. Think about like how do we actually create that algorithmic future. Then disruption management. One of the reasons why humans are in the system is they do really, really good job of managing disruptions and try to get back to basically nominal stage. How do we actually, in that future where the density and scalability is so high, is that even practical to have that kind of expectation from humans? So maybe we need better tools and automation that will allow humans to make certain choices, but automation does all the integration of information and then proposes the solution that will get us to the point where we need to be as quickly as possible, rather than having humans do the cognitive gymnastics all the time. And then movement towards management by exception. So here, this is the tricky part. So humans do really good job in uncertain things. They manage uncertainties pretty well, and that's what they are, the glue to all this basically uncertainties that exist in the air traffic management system. So if we really say that, okay, well, we need to have a automation to do all those things, can automation ever get to that point where automation will be so reliable that it can handle all the contingencies, off-nominal conditions, and all the uncertainties that are expected in the future? And then we can migrate towards management by exception. So this is still much of a research, and this is a vision kind of thing. It's not a done deal that we are going to get to that future, but attempt is to try to see if we can actually get automation to be so sophisticated, and then the research to basically back that up to say that automation actually is capable of managing that. And then the question becomes, what would be the human's role? And humans typically would be basically on a typical day, they will set up the goals for that. If everything is nominal, they will say, all my performance criteria, safety and efficiency and throughput and capacity, all have the same knobs and they are equal. But if there are disruptions happening, weather disruptions or runway closures or some other events happening, then humans can throttle up and down certain knobs and say, no, I'm going to basically put safety as a higher priority than something else. And the humans will have this supervisory kind of a role in that future, rather than only confine themselves to tactical operations. But fundamentally, there is this balance and paradox. So, if you want to get to that future scale density and simultaneously maintain safety, then we cannot overload humans. But we can't really take humans' role into something else unless we have automation that is proven. So this is sort of the dichotomy and the real juicy research that exists in this particular context, and that's what NASA is going to be working on, trying to figure out that right balance. But fundamentally, we want to embrace innovation in aviation, but at the same time, we have to respect the safety tradition, and that's that balance that we're trying to strike here. Thank you, and I'll be happy to answer any questions along the way.
All right, thank you all. So we have a question that's been upvoted, and the question is about using blockchain technology to secure ATM, and if there are any other relevant technologies to secure ATM. Do any of you want to speak to that?
From a cyber secure? Mm-hmm. We looked at blockchain at CANSO and put out a white paper on potential applications for blockchain maybe 2 years ago. It has some interesting applications. It's being used by the airlines right now, interestingly enough, for how they manage use of your frequent flyer points, because they're viewing it as a transaction of, I used my frequent flyer.
No wonder I lose my points all the time.
That's why you keep losing your points, that's it. So there are some interesting applications broadly across aviation. We did do a white paper on potential uses there are some parallels in the distributed network and how that is set up that might have some applications in ATM.
Well, so there's one, blockchain, of course, is useful, including, Michelle already offered a good example, but it's also useful for supply chain, part traceability. And then there is zero trust framework for those who are interested in cybersecurity and secure operations. ICAO has put together zero trust framework. I would highly recommend you look at that. There's also quantum com and a few other technologies that are out there for basically securing airspace and ATM at large. But ATM, you have to sort of unleash a whole bunch of things. ATM is not this one thing, right? So there is software involved, there's people involved, there is hardware involved, there's a whole bunch of parts involved, and information involved, data involved. So, and then infrastructure, communication, navigation, surveillance. So all of these pieces have their own basically uniqueness. And if you want to try to do security and aspects, and you got to couple all of these things together. There is also some other ideas about its own aviation.net and things like that. We don't really know which way it will go, but this will be one of the things that we will be studying for future. What would that look like? What are all the tenets involved? But there is a number of pieces that will come together. But definitely that topic is very important. Whether blockchain or not, the security is going to be very important as we move in the future, where there is more machine-to-machine interactions and information is shared, data is readily available, all of that.
I can also confirm from a European perspective, it's seen as like part of the basket of things we are looking at and we are researching and testing, but it's not the silver bullet technology or application that is going to address all of our issues. But certainly it is part of our research and development activities.
Oh, wow, we're getting some good questions. Thank you. So I have a question that has also been echoed by the audience. 25 years is a pretty aggressive time frame to make these significant changes that we've been discussing, especially based on the changes that we've seen, in the last 25 years. So how do you want to respond to that based on your specific visions?
It is incredibly ambitious, and I've been around aviation for more than 25 years now, and know the pace of change up till during the course of my career. What has gotten us here is not going to get us the tools and strategies and deployment techniques for technology that has got us here is not going to get us where we need for 2025. We picked 2045, as I indicated, I think, in part to deliver a really strong message that there is urgency for change. That people need to start paying attention to the transformations that will set the base for those future enabling technologies now. So we were purposely ambitious in that technology, in that timeline that we chose. But one thing I would say is we do need to find ways to speed up how we transform. And what Alain talked about of how we architect our systems along a more service-oriented architecture model will serve us well in that regard in allowing faster transformation over time and allowing the more of a Google App Store approach to technology where you can plug and play different capabilities and upgrade things faster over time instead of these huge vertically integrated big bang system approaches that ATM has so often done in the past that take 20 years in and of themselves. We've seen some of them. So we do need to do things differently in order to transform at that pace.
Yes, I'll just add that, yes, 25 years could sound faster than our previous generations of air traffic management system. But if you think about it now, if we go into the cloud-based environment and everything is in the cloud and not vertically integrated, and if we can use service-oriented architecture, you create containers, or in other words, modules for different services and common services across different platforms and such. If you get to that future, then it's possible that you can actually only update things that need to be updated rather than whole vertically integrated system that needs to be upgraded. So I think we learned from the IT industry in what's happening in Silicon Valley in terms of the service-oriented architecture and the cloud-based systems where you have these containers that allow you to modify certain aspects, just trajectory or just flight planning or just weather data or whatever have you. So I think that kind of future, I think, is exciting, and that will allow us to get to the future much faster, in my personal opinion. So I think FIA and I'm sure Europe too, that they are taking the first leap already towards migrating things into cloud. So as soon as we get into I think the cloud-based systems is going to have a big impact, moving forward. So I'm very optimistic. I can't really say 25 years exactly or not, but I think my view is the rate of acceleration of changes will increase significantly once we start to migrate towards cloud-based systems.
And I would add to that maybe also the just operational pressure, at least that we see in Europe. With everything we are putting in the pipeline for deployment in the next 10 years, we are not, if I'm like blunt, not going to improve the system. We are just going to avoid its degradation. But part of it is to, maybe to make an echo to what Michel said, we are putting in place these transformational enablers that are going to allow us to move and implement change at a more rapid pace than in the past, just by applying best practices of all the other safety and security critical sectors. So we see now a resonance. I mean, I've been with Cesar now for 15 years or so, so I can speak with a little bit of perspective. When I started in Cesar, people just cared about either cost efficiency or environment, or everyone had their kind of angle. Now you have people that are actually interested in just the value of speed. I want to be able to implement changes more rapidly. How is it possible that I need to wait 15 years to implement a change because I missed the boat of my latest major system upgrade, and I need to renegotiate 5 years, retrain the controllers, work in a regulatory environment that will not be ready for, for me to actually have the approvals to implement that. I mean, you are a CEO of an ANSP. That must be so frustrating when you have air traffic controllers that are in absolute shortage in our sector, and it will not be easier moving forward. We have traffic demands for use of sky exploding from just aviation and other sectors that want to use the sky for other purposes. And the last point is the methods of addressing these challenges that we applied as a sector in the past, which is either recruiting more controllers or cutting the airspace into smaller pieces, are not operationally implementable anymore, at least in Europe.
Yeah, absolutely. All right, great observations. Thank you. Do you have any thoughts on whether airspace will stay public or will it privatize between now and 2050?
Oh, God. I remember reading an article of a US-based publication, and they were, speculating that airspace would be auctioned off like Spectrum. And, I certainly hope not. I hope airspace will remain public. It is a valuable asset, and it is our intention with all of these visions to meet the needs in that airspace of all users and provide equity of access. So it is certainly my hope that it remains public and that those sorts of.
I would say that all three of these future visions all seem to assume that it will stay public, but have you had any thoughts about the possibility of it becoming private?
Asking me?
Either of you.
So from NASA perspective, we are not regulator, we are not policy or airspace or air traffic management. So I can't really say that's not. I didn't even take a policy 101 class, so I have no idea what that will be. But one thing we can say is that, joking aside, that the technology that we are putting together, it will be agnostic to however that's done. I think that's a business model and a policy issue, less of a technical issue.
I can add to that. Obviously, we don't take any stand on, let's say, regulatory aspects, but if I look at it from a business perspective, if you bring those visions together, the business of air traffic management will be different. Mm-hmm. It is not the same services as the ones that are delivered today. We are talking mainly about data services. Some of these data services are improvements of today's services. Some are completely new services that don't exist, that need to be organized. And I think that there needs to be a healthy debate on how can we make sure that we have the right actors that are becoming service providers in this domain, and mainly I think data service providers, to make sure that they also apply the safety culture that we have applied in aviation up to now. And that can be a very positive debate to have that doesn't necessarily overlap with state sovereignty issues, because here we are actually talking about how to create a common airspace where people collaborate on new services without necessarily taking away sovereignty of states. And we should not underestimate, in particular in Europe right now, the, let's say, defense dimension, security dimension.
And there's a lot of unknowns as to whether it would, what that means if you were to privatize airspace. Is it still operating within a regulatory framework? Are there still, I mean, if you look at the analogy between auctioning off frequency ranges, there's still the overall FCC that's requiring you to use the frequency bands in certain ways. And so if we were to draw that same analogy to airspace, maybe it doesn't matter whether it's public or private, as long as there's a regulatory framework around it that's guiding how that airspace has to be used and made available.
I mean, I would assume that the question around privatization of airspace also envisages a segregation of airspace. And, you know, we were really clear that there's going to be a need, and we're going to see segregation of airspace as an interim step, but we're really convinced that it can only be an interim step, that the optimization of airspace will require full integration, and the sort of roadmaps that we've laid out, you know, get us there. We may need to segregate for an interim period to enable certain types of operations and enable those operations to happen safely while we're putting in place some of these foundational elements. But we believe that segregation is a suboptimal end state if that's where we end up. So.
Maybe if I can add to that, because maybe the question was more formulated instead of airspace privatization, but more privatization of the way services are provided within an airspace.
Maybe.
If that is the case, I can see many potential futures. I mean, you could go all the way to an extreme as an airline. You could have one air navigation service provider that takes care of separations of your flights around the globe. I mean, why not in a data world, okay? As long as every one of those service providers is certified to provide those operations. Or into larger pieces of airspace. It's also an opportunity for today's air navigation service providers to bring more value to the table than they can today.
Sort of UTM upside down.
Yes, or multiple service providers in the same airspace. That's basically what I'm getting to.
Right, which is
Integration.
ultimately UTM. Yeah.
Yep.
Shoot, I just had an idea in it. Oh, segregated airspace. So this is something that I've been wanting to ask you all also, is that in some of the concept documents, it is proposed that the drones and UAS operate in a segregated airspace, and ultimately there's some sort of hybrid airspace where they could that we could transition to, and then in the far future, it would all be an integrated airspace and everybody's got whatever they need to be allowed to operate there. How do you see us transitioning? And this is mostly for PK, but you guys might have thoughts too. How do you see us getting to the point where drones can operate in an integrated airspace?
Good question. So let's talk about peel the onion. Segregated airspace, there may be a need for having segregated airspace in certain cases, like commercial space launches and re-entry. It's difficult to integrate drones operating when the launch is happening. That's not a good idea. But let's leave that aside. Other places, the way I think it is all about not knowing the intent of operator. So if you know the intent of the operator, you know where they are headed, then you can plan around trajectories. Goes back to my premise that if we share the information with everybody, create share and care environment, and all of it through right APIs, everybody is able to exchange information, then you can optimize around where you need to, around the constraints where you want to go. So So as I mentioned, the total system performance is where we want to go, and the more information I have about the constraints, whether it's drones are operating in certain area because there is search and rescue operation going on, or some other bad weather situation happening somewhere else, then you taking off from the airport, you are able to say, well, what would be my best trajectory to get to where I want to be? So I think it's really, everybody's on the network, everybody's sharing information, and you have ability to create trajectories based on multiple objective function that allows to get us to that future. So again, total system performance, network-based operations, APIs that connect information with each other, and information access. That's the kind of environment we can actually get together, except for the space launch and entry situation where you had to protect that airspace rather than a vehicle and a separation.
It's, drones are operating in controlled airspace now. They're just, it's a heavy manpower demand. It is operated on an approval and exception basis, but it's, there is sort of, in many areas, there is a do what you want below 400 feet. If you want to go above into controlled airspace, here's the approval process to get that. But we certainly are enabling drone operations now in controlled airspace in lots of places. But to have that scale is the challenge.
Yes.
And exactly as PK said, it is about getting to that, further along that end state of how are we sharing intent and how are we integrating them into a more planned trajectory-based operation in which everyone's intent is known and they can be appropriately deconflicted. It not with a sense and avoid type approach, but with a more strategic digital planning of the trajectories in that airspace on a more comprehensive basis. So that, hard to say, but that is more about how we achieve that with the traditional aviation and how we level up that to the capabilities that drones may already have to share their full trajectory and to automate their flight plan.
Right.
And in Europe, for the next 10 years, we are integrating RPAS into classes of airspace A to C. We have a dedicated regulatory framework that classifies airspace as the UTM airspace. We call it U-space airspace with specific requirements. And to unlock the first, I would say, innovative air mobility potential, we are leveraging low-level IFR routes, PINS approaches, so the more classical tool set. But when we then move into the 2045 era, I would say these questions of airspace classification, we leave the question mark open as to how should this be done in a world where we have a different allocation of resources around these scarce resources that are either a vehicle, a controller, a digital asset, a piece of airspace, a frequency, etc. And that is a subject of research itself.
One of you, and I don't remember if it was Alain or PK, mentioned something about tasks too complex to automate. And we have an upvoted question that wants to know what those tasks are.
I think it was in one of my slides. I don't.
Okay.
So we don't know what they are, but we see that there is a huge waste right now in the scarce resources that is the air traffic controller. That is by default manning every sector all the time. Sometimes we have fewer sectors open than others. What would be, a condition where it would be too complex for automation to manage? That is the first answer to the question. If you have just one aircraft traversing your sector and it's nighttime, maybe if everything goes well, this can be managed by automation. But if in certain other situations of traffic complexity, airspace complexity, time of the day, particular situation, and I'm not even talking about non-nominal situations, So this will be up to, I mean, that's one of the core challenges of our research right now is how comfortable could automation be in terms of self-declaration, and then how comfortable the human is in the way the automation is declaring itself capable. And we want to be able to design the systems for the maximum levels of automation, but it is a human that is going to decide, now I trust the automation on that moment, on that day, based on the information I have to do its work, or I take over. So it's a very dynamic way of looking at the task allocation distribution based on system capability. So I don't have an example like this right now because it is one of our core areas of research. But what is important is that we are not looking at a fully automated system all the time. This is not what we are aiming at. But
So
under certain conditions, and what those conditions are, we want to know.
So when you say automation, you mean automation and not autonomy? You're just talking higher levels of automation, and it would still be dynamic between the human operating it and the system doing the automatic tasks?
Yeah, so we refer more to autonomy for flying vehicles. We don't yet refer to it for ground system design. So when I refer to high levels of automation, I really speak about the separation tasks, for example, and the all of the tasks that the controller is doing today.
Okay.
We have a process we're launching where we are looking at how we plan the automation pathway. We know where we think we're going to get at an end state, and we've gone a little further than Cesar has in the timelines for that. I think that this is not a light switch that somebody's going to flick at 4 o'clock on a Tuesday afternoon and the job of controllers changes fundamentally that day. This is going to be a pathway of automation. And I think that how Europe is seeing it in the en route initially is an interesting way to look at it. But we do intend to launch a process of how we plan the automation pathway and how we assess the human factors issues along that pathway of how that will likely happen. I mean, we've had automation in ATM for a long time, and it has matured to a fair extent. The example I always give is medium-term conflict detection. We have great medium-term conflict detection systems that will project out trajectories in an airspace 20 minutes out and will see whether there will be a future conflict in that 20-minute window. Those started as alerts. We're just going to give the controller an alert that there's a potential conflict between these two aircraft 20 minutes out. Then they provided resolution advisories. And, the controller would be presented of a solution to this conflict is, change the speed, altitude, or trajectory of one of the aircraft, and that will resolve where medium-term conflict detection is now integrated with CPDLC, the controller gets the alert that there will be a conflict, a resolution of advisory of what would resolve it, and a pre-formatted CPDLC data link message to send to the cockpit to give them that instruction to make that so. The automation has incrementally changed the nature of the task and the challenge for controllers in that aspect. And it isn't a leap to see an eventuality where the system that is identifying the resolution advisory, pre-formatting the message to the plane, just sends that message without that human being in the loop. It isn't a leap to see how we get to that type of automation in an en route environment.
Maybe if I can underline something that I think hasn't come out enough in some of our debates, and I think this is an opportunity to throw it in. None of this is possible without investing massively more in the next generation of air-ground connectivity. I mean, all of the investments we would do in automation on the ground would not make sense, be safe, without a higher level of air-ground system integration.
Network. Everybody needs to be in network.
Hyper-connected ATM. Yeah.
Yeah, but to answer the question, what's hard? Some of the things that are hard is ultra-reliable speech to text, like 100% reliable speech to text under very noisy conditions all the time. It's not. We have been trying, and we are getting closer and closer, but getting that ultra high reliability, 100% reliability, we got to prove that. But one other ways, we can do that is we have cloud-based system, we have algorithms, we can put them in the shadow mode in a digital twin and keep testing them. Previously, there's always question like, oh, do we have enough data to show this, that, and other? Now, with cloud-based systems, you can actually put your algorithms and new ideas and test them using digital twins. So you can get enough confidence when you are doing that. And then you say we have enough confidence to actually take it to operationalization of certain things.
Mm-hmm. But we do need to get away from speech as well.
Speech to text is very hard.
Yes.
Reliable.
Let's do away with speech.
Digitize everything.
Yes.
That's right.
Yes. That is a limitation. We looked at issues in Canada a number of years ago, and one of the dominant complexities in air traffic control was frequency saturation. We are saturating the frequency, and we are creating latent safety issues with frequency saturation. Yeah. We do need to get away from speech.
See, which requires that you have a lot more strategic decision and basically clearer strategic plans and sticking with them. And if the changes are, those are machine to machine basically communicated, and reducing a lot of these tactical instructions. The speech works really well for executing tactical things. And if we can reduce the need for tactical clearances, then actually we will be able to be successful in getting.
Yeah. It's an interesting dependency. So speaking about speech maybe in some areas being required and in other areas having reached digitization, so harmonization. How do your visions accommodate where perhaps one region is at more advanced levels of automation and then the aircraft transitions to another one? Is that going to impact separation? Is there going to have to be lower density in the less capable airspaces? And how is that going to impact overall capacity?
Yeah, I mean, we think that, we are rolling out our concept of operations on a global basis. We are in active conversations with all of the regions and the ANSPs in the regions about the path and how that path will be tailored for them. Density of traffic is not a significant issue in Africa, and in 2 weeks' time, we're in Africa talking to all of the continent's ANSPs about this roadmap, their place in it, what it looks like for them, what their priorities over the next few years need to be. We will see really interesting applications of drones and urban air mobility in all regions of the world where it has the possibility to solve real problems. We're seeing really interesting applications of drone use in Africa right now that they are able to enable because they don't have some of the density of traffic problems that Europe and the United States do. So they do have an interesting opportunity to leapfrog to some really advanced steps. So those conversations are happening right now. But there needs to be a harmonization of capabilities for concepts like trajectory-based operations to work globally. This needs to apply to international long-haul flights. We need to be able to share trajectory, to have negotiated trajectory changes en route that get updated to the other ANSPs further along the lines. It doesn't make sense for us to have a mature trajectory-based operation system that operates in a small piece of the world, and then we're back to tactical management of flights elsewhere. So we do need some level of harmonization on these capabilities across the regions and need to be working towards that.
Yeah, I'm also convinced that there is a need for global harmonization on many of these aspects. I think there is, on many of these aspects, also still a lot of research that needs to be done until we really know that this is mature enough to say, okay, now let's have a concrete debate on these aspects. In particular, if we talk about the automation levels that we have been aspiring to in our presentations, there is still a lot of research and development that needs to be done. But do I see that there will be issues to resolve if you are a pilot you need to be aware of the level of service you're getting in certain types of airspace and whether you are speaking to a, let's say, digital air traffic controller. This should be completely transparent. It should be with procedures attached, et cetera, what to do in non-nominal situations, and so on and so forth. Or if you are then in that sector with a digital controller and the next sector is a human controller, how is a handover between a digital and a non-digital controller handled? If that sector happens to be another country, how does that work? What is the implications for the infrastructure? I mean, I could list questions and questions and questions, but they are all for me research questions that are healthy questions. But do we see a need for global harmonization on some of these aspects? Yes. That's where I think that it's very important for us to actually share our visions, bring our visions together, bring our efforts together, and our research communities together on some of these topics.
Do your visions call out harmonization in your documents, in your comments? Yours does.
Yes, absolutely. Yeah.
So we map all of our either deployment priorities and development priorities against the Global Air Navigation Plan, and we are a contributor to this process, so it's completely mappable towards a global agenda. What may differ for us maybe is more the timelines attached, where we try to be maybe a little bit more ambitious than certain regions on certain points, where we also, in our dialogue, for instance, with our US colleagues, we go to a level where then we really discuss the concreteness of what we mean behind certain things. And we know that in the area of, let's say, trajectory-based operations, that is a big area where we need to work together. The next air-ground link is another area we need to work together because the two are dependent. But I can imagine already a number of things that maybe we don't speak enough about at present. If we move towards this new environment, like how will we give confidence on software assurance for ground systems that are developed in completely different ways? I cannot see EASA being comfortable in just having a European approach and stamp on this is a certified system for, let's say, separation service processing without us having actually a global reflection around this. This is just one of these examples that could surface very rapidly.
There's a question about integrating space launches with air traffic. How can we accommodate increasing numbers of space launches? And so, while staying safe.
This was a significant conversation at the ICAO Air Navigation Conference, the global conference of countries last year, and will be again this fall at the ICAO Assembly. There are a lot of conversations happening about how we illustrate best practice in that. There are lessons to be learned. A lot of them are lessons that the United States has learned. You guys have done as many launches as anyone. And have learned with each of them how we do that integration, how we work with launch providers on timing, selection of day, those sorts of things in order to minimize those impacts. We've put out guidance from CANSO. We have another guide that's coming out for ANSPs and for commercial space launch operators on exactly this topic in the next, I think it's coming out in the next few weeks. But this is a big issue when we look at the states that are now impacted, not just from the launch itself, but potential danger areas that will impact multiple countries, and how we coordinate that, how we NOTAM that, what airspace needs to be closed.
Can you make it dynamic?
Are we doing it in a common way? How do we get to dynamic identification of that? These are all really important issues and a growing conversation that's happening amongst ANSPs. We're bringing SpaceX to our Latin America conference in a few weeks to talk exactly about that and how we do a better job of having a common approach to how we do the risk analysis and how we identify the size of the danger zones for different types of launches. We need to get better and more common on that. And ICAO, I have to say, it's been a gray area. They don't have jurisdiction over space launches, so they weren't doing much, and that common conversation wasn't happening. I think we're past that now.
Cool.
Yep.
In Europe, I would lie to you that it is the most central topic, and I think it is much more in the US, but it comes up. And when it comes up, it is more handled by, okay, we can do better collaborative decision-making, network planning. But we are then really into the domain of how much airspace do we need to close when, et cetera, et cetera. So that is more in, I would say, our network managers that would deal with this and making sure that it is properly planned and that there is no unnecessary disturbance. Do we have a technology solution for that at present? Or do we look at a specific technology solution for that? Probably not, but then we are looking more at, let's say, higher airspace operations in general. We have conversations on also moving the barrier between ATM research and space traffic management research. And we have some healthy conversations on this, but at present, I would say these are more niche conversations, at least for us in our program, because we don't have an immediate technology solution or project that we could focus on. But we do it more from an exploratory, conceptual perspective, not a technology perspective at present.
Yeah, so on the space traffic management, clearly, I mean, as Alan said, US has the most space launches. It will continue to be like that for foreseeable future. But there are two aspects. One is entry and exit in the airspace that where ATM also operates, and one is space traffic management once they're on orbit. So let's just talk about on-orbit space traffic management. We have a similar concept like UTM where it's cooperative. They share the information about orbital trajectories, and if there are any deviations, then they can actually inform each other through electronic means across the globe so that they can figure out if the satellites can be moved out of the way. Some can, some cannot be moved out of the way. So there is definitely, as there is more density in low Earth orbit, there will be interesting challenges about how do we actually make sure that these satellites have some level of maneuverability so that they can continue to maintain the safety of overall operations so that there will be less debris in the future. So that's one. That's the space traffic management on orbit. And we have a patent, by the way. For those who are interested in that, check out NASA patent on space traffic management. Second is the entry and exit. And part of that is previously was just going up, and now we have re-entry vehicles also. So interestingly, you had to do the debris management and debris protection for basically launches, but now you also had to do for re-entry. And that is interesting problem also, so that you need to know where exactly that coming back, the rocket or shell is, and then you need to move aircraft out of the way or plan it in a way that actually is going to manage the efficiency for all the operations. And this goes back to that total system performance management. Once you know where and what time these operations are likely to happen, launch and re-entry, then the operators can figure out what's the best way for them, taking delay on the ground or basically taking a reroute or doing some other path. And if there are other complications like weather in some certain pockets or other density going on in some different locations, then you have to really figure out what's right for your business objectives. Now, part of this is basically when the launch operators, the operators who are launching, give their planned window a few months in advance, then they need to create, basically the FAA's office has to create a plan, right? What's the plan for that particular day? Am I going to reroute aircraft? What's the best strategy to maximize the efficiency and reduce the impact? And that is a very laborious process. So we are working with FAA and others. You know, there is a tool that we work together with them called Sport that allows you to take the information about the launch window and then figure out what's the right way to organize the traffic. So at least in the planning stages. And then slowly we want to try to get to a point where you can not only do the planning a couple of months in advance, a week in advance, but also on that particular day in a real-time way so that you know exactly where these vehicles are, where exactly the re-entry is. If you put ADS-B on that, so you'll know exactly where that is so that you can keep clearing the airspace as soon as that vehicle or the parts of the system are basically crossing the particular altitudes. So there are lots of interesting ideas, but all of that starts with information exchanges and knowing what the windows are and real-time exchange of understanding where the vehicles and the subsystems are.
Everything starts with information exchange. It's like the fundamental, it's your fundamental transformation. Thank you,
Yep.
transformation one, right?
It's hard to get to common situational awareness
Yeah.
if we're still managing flights on paper strips that controllers write on. It's hard to get to shared situational awareness.
It's definitely hard to get to performance-based airspace with just speech. Yeah. I mean, and if you take PK's idea of the performance-based airspace to an extreme, everything is, you're dynamically changing the requirements in any given airspace based on what's going on. That would be part of your space debris management. And the vehicles know whether they are allowed in certain airspace based on what the performance requirements are. I mean, it solves a lot of problems, but how do we get there? Yeah. So now there's a lot of sort of one-vote questions. So there's a question about all the mishaps that have come up and accidents in the news lately, and how are we going to, what can we do in a shorter time frame than 25 years to address them? It's kind of different from planning future airspace management or air traffic management, but do you have any thoughts on that?
My thought is you are in the better position to answer that question, being the Flight Safety Foundation. Joking.
Thanks.
Joking aside, I think they are studying all the root causes and things that they have identified as the communication and infrastructure. So I think FAA and the Department of Transportation Secretary Duffy has taken a big step towards upgrading all the things that are needed so that there will be less degradation moving forward, right? So the communication, the radar system, the surveillance, all of the backbones that right now kind of getting old and jaded, they need to be upgraded, so that's happening. Once that's done, then you get to that information stage and then say, okay, well, how can I use that? We can't get to that stage till we have this old system that's not reliable in terms of infrastructure. So I think that's the first step. So, Congress are allocating $12-point-some billion and under Secretary Duffy's leadership, I think that's awesome. I think that's really first crucial step. And I don't want to sound like a government worker, but really it's important to upgrade that infrastructure. Then we can right on top of that, as soon as that is done, to start putting automation and algorithms and newer types of basically operations, because now we will have a reliable backbone that's available for exchanging communication. We have copper wires and we have basically
Monolithic systems.
Old voice comm now that's going to get voice over IP. All that stuff, I think it's going to be really interesting and very useful for going to where we want to go towards this network-based operations.
Yeah. Maybe the only other thing I'd add to that, to what PK had to say, is aviation has accidents are still relatively rare, knock on wood, in aviation. So we have the issues of how do we continue to investigate, and how do we get better, and how do we understand safety in our system with so few incidents?
Yep.
And so we are really convinced that we need to move towards more predictive risk metrics that allow us to understand not just compliance issues of, did we have a runway incursion, did we have a loss of the mandatory separation standard between aircraft, but what's our risk exposure? And so there's
Learning
a lot
from
of
all.
conversation going on about time to conflict metrics, which is an entirely different way of how we look at potential risk in the system, that allows us to work at eliminating some of those latent risks we maybe don't know are there. And I think that will, I think a lot of the digitization that we've been talking about is going to give us so much more data to understand those risks in a different way, but we do need to move past sort of compliance approach to how we look at safety and mature our thinking there.
And I will throw out that the Flight Safety Foundation has been key in working on safety from all
Yes.
ops, where it's addressing exactly what Michelle was talking about. Instead of just looking at binary, were you safe or were you not safe, where in your safety envelope are you operating? And if you can understand that consistently, maybe you realize you're operating on the edge, even though you thought you were more in the center of that.
Even though nothing happened.
Right, even though nothing.
Mitigations.
So you have improvements that you can make.
Yeah, years ago, I worked on the project dynamic density. The whole idea was to look at basically how many degrees of freedom each aircraft has in a given situation. So can you go faster? Can you slow down? Can you move up, down, turn right, turn left? The less degrees of freedom aircraft has, the more constraints and more risk that exist. More degrees of freedom, the less risk. So I think this is part of this total system performance management, is understanding what would happen if I go this route. Am I going to be in a situation where I will have very little basically options to maneuver in case something goes bad, or if I go that route, I have a lot more options. So I think not only your time and fuel consumption and throughput and all, but you also integrate the risk along the path. You know, continuous risk assessment, continuous assessment of total performance is really critical, you know, in that sense.
Well, and that's a perfect lead into, I think, maybe the last question we'll have time for, which we've been talking around, I think, this whole time. And the question is, how do we think the ecosystem with UAS, AAM, commercial and military gets synchronized in air traffic management by 2050?
You want to go first?
Yeah, I mean, it's all of the bits. You know, military is not one that we've talked about, but that is our ultimate segregated airspace still. You know, we're working on that one, but that is still our ultimate segregated airspace. It really is, it's all of these things. It is the foundational elements of how we get to electronic conspicuity, how we get better digitization of our data and better common situational awareness and what those data exchange models are, how we get to, you know, it's hard to do full integration of autonomous aircraft if we can't get machine-to-machine communication with our traditional aircraft, and we need to get there too. So it really is all those bits coming together towards that final.
The end state we're trying to describe.
I mean, for Europe, we are engaging with all of these parties. So obviously, there is the working together and having a home for daring to collaborate. And I think the research and development phase is probably one where it should be easiest to collaborate. So we are creating this environment and caring for it as much as we can. But I also think that fundamentally we need to bring the aircraft at the center of optimization, which is something that is going to be a huge technological challenge, where it doesn't matter what type of aircraft you have. Everyone has a capability that is much stronger than today. I don't think that you will be able to solve it by just having the beautiful supercomputer centrally located somewhere. And that goes into actually optimization capabilities and how the different capabilities are distributed between ground processing capabilities, vehicle capabilities. But we need much more capable aircraft, and that can be done by just providing the aircraft with much better services in a digital form, irrespective of if you're a military, autocraft pilot, onboard an advanced air mobility vehicle that takes you to the city center from the airport, or A350 or 777X pilot.
You want to add anything?
Well, I do think that we need to relook at the architecture completely and figure out what the right architecture is, and not just adding patches to that. So I think we, you know, like I said, cloud-based connected system, security, all those aspects, safety monitors on top. Those things need to be all relooked at from the architecture a little bit top-down perspective. And then we had to have certain principles, flexibility where possible, structure where it's necessary. So we should be able to give demand-based, performance-based, risk-based operations, but in case we need structure, the system should put those structures. Yes. Another one is integration where possible, segregation where it's absolutely necessary. You know, we had these like certain kind of mantras that we follow, but the system should be able to keep up with that, you know, on both sides in case it's needed. And you do need them because there are larger uncertainties, larger weather problems, a lot of constraints sometimes come together, in which cases you had to put demand capacity balance type structures, you know. So that system should be able to do that in a dynamic manner. And for that, we really need to relook at the architecture completely and the roles of humans and machines in a way that we can adjust it based on these changing things.
It's exactly 5. Actually, it's a little later. But I think I really want to thank you all for sharing your visions. It's a bit of a relief to know that everybody is trying to move in the same general direction, and that's going to help in harmonization in and of itself, and also help the research world understand what the next long poles in the tent are and where to put their energy to try and enable these future visions. So thank you very much.